Hey guys, welcome back to my channel. And today we're going to do some math problems. So let's get into it. All right. So today we're going to be working on 2.6. And this is number 8. Okay. So we've been talking about this and we started this problem last time and we're just going to continue. So the other thing was this problem here was how much more interest are they going to collect off of 3/4. And we were using this formula. Where's that formula? Here's that formula right here. And all you were going to do was plug it in, where you were going to plug something in. What are you going to plug in if this is the prompt? Find as many ways as you can to answer Carlos's question. How much will their account be worth in 3/4 of a year, 9 months, if it earns 5% annually? Okay, so where are we going to plug this 3/4 in? Where does the 3/4 go in our equation? Very good. It goes in our exponent. So that's what I'm going to have you guys do right now. I'm pulling over here. I want you to do that right now in your thing and then actually calculate it. Pull it up on your calculator so I can see how you're calculating in here. Practice using the calculator because that's going to help you a lot. Okay, so I'm going to pause and you guys are going to plug that in and then we're going to come right back and check. So I was peeking at your answers and they look really good. So a couple people wrote their formulas here. I actually want an answer as well. So go ahead and plug it into your calculator and tell me what you got. Very good. Use the formula now, plug it in. Very good. Now actually plug it in and give me the answer. Let's see, this person said, ooh, here's the answer. Yeah, put this answer right here so that we know. I like how this person did this. Fancy footwork, whoever this is. So, so this person's like, oh, I wonder if I put it as a decimal, would it give me the same as a fraction? Very good question. I love the wonderings that you guys are doing. So let's just say that they check their account, Carlos and Clarita, they check their account at the end of the year, right? And they have $397.15. Are they going to be like, what the heck? The bank stole from me? Or are they going to say like, oh, okay, that makes sense. Which one are they going to be? Yeah, they're going to be like, okay, that makes sense, right? Very good work. Okay, let's move on to the next slide. Good job, guys. Okay, next one. Where is it? Here goes. So Carlos now knows he can calculate the amount of interest earned on an account in smaller increments, on smaller increments than one full year. He would like to determine how much money is in an account each month that earns 5% annually with an initial deposit of $300. He starts by considering the amount in the account each month during the first year. He knows that by the end of the year, the account balance should be $315 since it increases 5% during the year. Make sense? Okay. So complete the table to show how he does this. So go ahead and you're still using that same formula. Can someone give me that formula in the chat based on this information here? What would the formula now be? What would the formula now be? Okay, so in case you need a split screen on that, let me show you. Here's that equation that we were using, but some information has changed, right? Some of this information has changed. Which number has changed? Now, if you're really getting better at this, you are knowing exactly why the $382.88 goes here, why the 1.05% goes here, and what N represents. So what is the formula going to be now for this guy? For this one right here, kind of, except for how much money is Carlos starting with in this case? Very good, but how much is Carlos starting right now in this case? It is asking for a month. Yes, very good. Okay, so some people said, hey, Miss Johnson, should I put 300 in the N? Or do I put 300 as the $382.88? Exactly. It goes right here. So let me clip someone's, where is my little tool here? Yes, let me grab this. So someone said, Miss Johnson, is this my formula? And I'm going to say, yes, exactly. This is your formula. Now, the reason why this one is your formula, and let me put it in the right spot, goes here. The reason why this is your formula is because numbers have changed. Why does 300 go here? Why does 300 go here? Yeah, that's the money. That's the base amount that we're starting with. So for example, when you guys get a little older, I'm just going to encourage this, okay? When you start making money, take $50 a month and put it somewhere. Put it in a college account, put it in a retirement account. And you guys are like, Ms. Johnson, I'm seriously 17 years old. Retirement is way far off. One of the things I hope that you learn in this chapter is that time. Like if I had to say what's more powerful, starting with $1 million or how many years that you're sitting there with, it's the number of years that's the most powerful. I can start you off with $300. And if you put, okay, let's see, if you start this at 18 and you do this until you're, I don't even know, let's just say that you plan on retiring early and you're going to go till, I don't know, 48, just so that it's an even number. So 30 years. That number is ridiculous compared to if you start with $300,000 and you only have it for 10 years. Okay. So the biggest factor, the biggest number that has the most power here is not this. It's not this. It is this. It's the number of years that it's sitting there. Okay. So for those of you who are like, but Ms. Johnson, $50 isn't going to do a lot. Well, okay. If it's not going to do a lot, then it's okay for you to just ignore that $50. So I can't tell you, I can actually show you a really neat screenshot of a comparison, but I'll do that later. So right now, you should know why this person put 300 here, right? Why did this person put 300 here? Oh, because that's the amount of money that we started with. Very good. Where did this 1.05 come from again? Where did the 1.05 come from again? Yeah, it's your interest. And why is it 1? Because we're adding on top of it. This is what you guys said last time. Very good. And the N is your N. So I want you to plug it in here every single time. And I want to see what your answer will be. Okay, so go ahead and do that. And we'll come back and check. Okay, so what you were supposed to do for this part, and I might annotate just a tad here. Oops, what am I doing? So for this problem, they asked you, so Carlos, he's on a different thing now. He's like, okay, well, what happens if I start with $300, not this $382.88, right? So that's why this person chose to put this here, right? So one of the ways to do this is doing it the way we all did it with this formula. Another way to do it is how we did it before, right? And the way we did this before, and I have to grab my iPad real quick. The way we did this before was we looked at, do you guys remember doing this? We looked at, well, because this is the number, this is the end number, this is the beginning number, we divided. Do you guys remember that? And then because we divided, we just had to count the number of jumps. Do you remember doing that? So when we count the number of jumps, hold on, let me find it real quick. So we're going to say, and I'm going to do it a completely different way than the way that you guys did it, just so that you guys are all on the same page. So I am taking 315 and dividing it by 300, right? So whatever that number is, and we should already know what that number is, but that's okay. So where is my calculator? Oh, it's right here. So here's my Desmos. Okay. So I go 315 divided by 300, and it's 1.05. Does that number look familiar, you guys? Yeah. Okay. Okay. So 315 divided by 300 is 1.05. You all knew that. That's something that you knew. But then because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 jumps. Do you remember us writing this equation like something to the 12th equals to 1.05? Do you guys remember that? Do you remember this equation? Yeah. So the other way to do this is if you didn't want to use a formula, we can use this kind of like old school method. And so how would you get rid of the 12th? So remember when you got rid of the squared, how did you get rid of squared? Right? How would you get rid of squared? And you guys said, oh, we just square root it, right? Very good. So here you're going to do the same thing, except for here, we're going to 12th root it. It sounds funny, but now there's a 12th root here. And the way we plug that in case you forgot, remembering that you're just going to take this, to the calculator to the 1/12th, which makes sense, right? Because that's exactly what you guys did over here, right? That's exactly what you did over here. So I'm just going to multiply this. This is going to be my multiplier. I'm going to multiply this by 1.05 to the 1/12th, which looks really funny, right? So I'm going to show you on the calculator what this actually means. So I'm going to put this in parentheses. I'm just going to leave it exactly like that because I already know that that's that. I'm going to take it to the 12th. So the number, the actual multiplier I'm multiplying by is 1.8-ish. Is that right? Did I do that right? 1.05 to the, oh, not to the 12th. Goodness gracious, Miss Johnson. To the 1/12th. Woo! That would be great if it was multiplied by the 12. I was like, wait, something is wrong. So it's one, we're going to multiply it by this number. So I'm going to take 300 and I'm going to multiply it by that number right there, which if you look at, this is the 300. This is your 1.05 and this is that number. So I'm going to multiply this by 300. And do you see that's the number that you should have gotten in that first one. So let me pull this off here. And let me pull this like this. There you go. So we go here. And then we're going to look at some of your answers. And so some of you got, 3.0122, 3.024. Yeah. And if I change this to the second, yeah, very good. In general, whenever we're dealing with money, you usually grab at least the 100th place. So whoever did this, you did it right. I'm just telling you, just in future, that's what you're getting. Look, I'm getting all these right answers. Very, very strong work. You just multiplied very good by 1.05 to the 1/12th. Very, very strong work. So what you just figured out right now is if you don't want to wait till the end of the year, Carlos can pull out his money at any point during the year. Now, some of you are thinking, Ms. Johnson, to wait a whole year for $15, that's nothing. Okay. The whole point of investing money is that it's like time is your friend, right? Because that money is going to sit there anyway. So do you want it to sit there earning no interest and you get $300 back? Or would you like it to sit and make money while you're sitting there, right? Very strong work. Very, very good. Okay, let's move on a little bit. So the next question says, we answered the next question. It says, Carlos knows the exponential equation that gives this, and this is what we figured out, right? The account balance for an annual basis is this. Based on work he found for each month, Carlos writes it like this, right? Right? Do you guys all see this? Now, some of you are like, Ms. Johnson, we didn't do it like that, and we still got the right answer. Yeah, but look at, if you see the 1/12th right here, and the 12, these two, when you multiply, right? It's just going to give you a T. And that's what they're asking you to do here. I'm kind of going through this part. So in this case, what does 12T mean in this situation? What does 12T mean in this situation? So for this, I'm just going to answer with you just because I want to make sure that we're all on the same page. It says, based on this work, the account balance for each month, this is the month calculation. This is the year. So this is the same. Yeah. These two are exactly the same. The meaning of 12t in this case is you're basing this off of the fact that this is a month. This is based on the number of months. So 12t would represent 12t would, hold on a second. Okay. So this 12t represents 12 times the number of months, which would now be a year. So they're basically telling you, hey, do you want an equation that's based on the number of months you're going to give me or the number of years? Okay, yes, exactly. That makes sense. Very good. Just gonna move on. So Carlos shows his equation to Clarita, and she suggests that his equation could also be approximated by this 300 times 1.04, 12t. Since 1.05 to the 112th, remember we saw this 1.04. Where is that guy? Oh, we erased him. He's right here. I make this a 1. Remember we saw this guy 1.004. So Carlos replies, oh, I know that 1.05 in the equation, blah, 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 is the meaning of 5% annually, but what does 1.04 mean in your equation? What does 1.04 mean? What does this now mean? If I gave you this equation, 300, you guys are comfortable with, you'd be like, oh, Ms. Johnson, that's the money. But what does 1.04 mean? What does 1.04 mean? It's okay. You just keep paying attention. Your whole goal is just to learn a little bit more. So what does 1.0, what in this equation right here, what does 1.05 mean? Oh, I think we're a tad lost. Yes. Okay, good. So 1.05 refers to the 5% interest. Yay. If you said interest, yes. Good. Interest when? Interest when? Interest when? Keep reading, Oh, per year. Very good. So what does the 1.004 mean? It also means interest, right? But for when? I gotta clip these because your responses right now, guys, are ridiculously amazing. Ridiculously amazing. What's happening? Hold on a second. Okay, let me grab. So yes, so here this is per year. We got this. Where are we here? So this 1.05. This is per year, right? 1.05 is per year. What does that 1.04 mean? Oops, let's just put it here. What's the 1.004 mean? Yeah, this is interest per year, but 1.004 is going to be interest again per month, right? Because that's where we got it. Look, you guys said, right? That's per month, right? 1/12. Not per 3 months, just per month. Very good. Per month. Very good. Very good. So for those of you who are a little bit lost on this, just focus on this. So wait, Ms. Johnson, these two equations are saying the same thing. Everyone say yes. Yes. Okay. But Ms. Johnson, they look really different. I know. But what's the difference between these? Okay, so let's read carefully. 300 times 1.004 times 12 to the t is what? When would I use this equation? When would I use this equation? So I'll do it over here. Carlos should use this equation when, yeah. So let me just type because I can type faster. Carlos should use this equation when he is trying to calculate how much money will he have based on the number of months. Does that make sense? Months. I'm talking months. Okay. So let me just highlight this so that you guys all see this. Ah! I don't know why I did that. Okay. He should use this equation whenever he's trying to calculate it based on the number of months. Okay, months. When should Carlos use this one? When should Carlos use this one? When should Carlos use this one? Yes, not months. Ms. Johnson, you're gonna just copy and paste that whole phrase? Yes. Because you should use this one when it's on years. Does that make sense? Ms. Johnson, are they going to give you the same answer? Yes, as long as you calculate